When it comes to hanging, PPE required, not nearly as much as all the other stuff we do, but we're always going to have safety glasses still. And then gloves. Gloves are very important when you're hanging in the coating industry, especially powder coating, because it's almost always metal parts, which means there's sharp edges and corners that could cut you. So gloves are super, super important. When you're hanging, the main thing is just you need to try to plan ahead. What we mean by that is as you're getting ready to hang a ton of parts for a job shop, let's say multiple carts, or if you're on an automated line, multiple load bars is typically what they would call them. You want to figure out how many carts or load bars this is going to take, and then what orientation do you want to hang the parts in so they're easiest to pre-treat and then also coat, and then hanging those efficiently. So we try to always hang everything in a very similar fashion. So if a part is going to be hung a certain direction and a certain orientation, we hang that the exact same way for all, let's say, 1,000 pieces. That way you don't have all these different weird orientations and turn differently, because then as you're pre-treating or you're spraying powder, you're having to change the pattern constantly. And so you're just introducing a lot of extra variables because you have all this weird orientation instead of being able to just do everything in one nice smooth motion, and every part gets the same contact time and same amount of chemical or powder on it. When you're hanging in a job shop on carts, it's important to hang from as far away from you as possible and then work your way back towards yourself on a cart. If you hang up really big parts right in front of you and then you have to walk around them to get to the next open area on your cart to hang, you're making a lot of extra walking effort, and it takes a lot of extra time to hang that cart, versus if you just hung the parts far away from you and worked your way back towards you so you weren't always having to walk around obstacles, basically. It would take almost half the time. So that's what we mean about planning ahead. It's just looking at how the parts are going to lay out, how many carts or load bars you're going to need, and then just doing it in the most efficient way that you can, so you don't end up just wasting time simply because you're having to take a lot of extra steps or a lot of extra movements. You want to make sure that you're always using the right hook size for the parts that you're hanging. The obvious one is if you have a really, really heavy part, you're going to need a big hook, like a 1/4 inch diameter hook or bigger if you're hanging very heavy parts, because otherwise the hook could break. The problem is you can't always just err on the side of, well, I'm just going to use a really big hook all the time. That way, no matter what, the hook's not going to break and the part will be able to stay hanging. The problem with that is when you get lightweight, tiny parts that when you hang them kind of rotate or turn and lean against the hook. If you're using a very large hook, that leaves a really big area that's covering or shielding the parts, so you can't get as good a pre-treatment, and then you're obviously not going to get powder as well behind those hooks. And so that could create shadowing or light spots, or what we would call a hook mark. Once they come out of the oven, you go to package the parts, you can actually see where the hook was either laying against the part or just kind of hanging in front of and shielding it, because the hook ended up being very close, or just the area where the hook is touching the part because it has to hang it. You can leave a way bigger mark there if you're using huge hooks. So if you use a huge 1/4 inch diameter hook on very tiny parts that are very light, that just doesn't make sense, because you're leaving huge hook marks behind on these tiny parts that you could have easily hung with a smaller, thinner hook, because the parts were light. So some of it is common sense. If it's a very heavy part that you're lifting and it takes 2 people to lift that part, you're obviously not going to be able to use a super tiny hook. You need something bigger. And then if you have very lightweight parts, then you could use a thinner hook. If you do overload hooks, like we just talked about, they can break. Most of the time what happens, instead of a hook literally failing and like snapping, typically they're kind of in a C or V formation, so they're V's at the ends of the hook. And so when you go to hang that part, the vertical part of the hook that's kind of connecting the 2 ends together, it kind of starts to arch. The back of it starts to arch. The V's at the top and the bottom kind of start to open up. When you're loading it too much, it kind of basically wants to take that hook and splay it out and make it straight again, essentially. You usually can notice that if you're hanging a very heavy part and the hook's too small, and you can kind of start to see it splaying out. But the one thing that you need to keep in mind is when you put the parts through the oven or in the oven, the metal of the hook heats up and it makes it a little more flexible. The heat does. And so then it can open up even more. And typically that's where you'll see parts fall off if it was borderline that the hook was too tiny for this heavy part, because in the oven the hooks continue to open up to the point where then the part falls off. So typically it's not the hook just breaking and snapping in half, kind of like we have here. It's more that the hook bends to the point where the part just falls off. And that's a dangerous situation. Usually you can tell right away when you hang a heavy part with a lightweight hook, because you'll see it start to splay and open up. And then that's a sign that you need to grab a bigger diameter hook is what you typically need to grab, because you just need more material. You need that hook to be thicker. And so then it's stronger, and then when you hang the heavy part, it doesn't move at all. The hook just stays as it is, and there's no deformation of the hook. When you're nesting parts, which almost everybody that pattern coats does this, especially when you have tiny parts, you just have to keep in mind that even if you have a lot of lightweight parts and you're nesting them and you're doing 10 or 15 all the way down in a nest, so in like one vertical column, that hook at the very top is holding the weight of all of the parts in the nest. So sometimes that hook at the top actually needs to be a little bit heavy, more heavy duty, because it's holding so many parts, versus the hooks in the middle of the nest or towards the bottom of the nest, they're only holding a couple of the lightweight parts, so you can get away with a lightweight hook. So just because you have a ton of lightweight parts and you're trying to get away from hook marks, so you're going to use a small diameter hook, and you're thinking this isn't going to be any problem, it probably won't. But the ones at the very top of the nest, the hooks, or maybe second from the top, those are carrying a lot of load still that you don't realize, because you have hung all of these pieces, lightweight pieces, in one nest or vertical column, and that could start make this hook at the top deform and open up. So you might need a more heavy duty hook at the top of the nest. Another thing to consider is sometimes hooks aren't going to do the job. In a job shop setting, usually the parts can get very big and very heavy, more so than an automated line, because an automated line usually doesn't necessarily have the weight capacity for thousands upon thousands of pounds. So when in a batch setup, that's usually where you have extremely heavy parts that you're hanging with a forklift. When you're doing that, you're hanging parts that are very heavy and you're having to use a forklift to do it, because it's not possible for two people to lift it together because it's too heavy. For one, you either need really, really big diameter hooks, which they do make, or you need to start using chain and eye bolts. For one, typically chain ends up starting to be a little bit cheaper than really big diameter hooks, at least from what we found. And so chain's readily available at local hardware store, and it can hold a lot of weight. The problem when you use chain is if you loop that around a part, let's just say, well, obviously the chain links are laying up against the side of the part, and there's no way you're going to get coating behind that, and it's just going to look terrible. So that's not a good solution. Typically, really huge parts or weldments have holes somewhere because these parts are getting bolted or mounted to something. Usually you can put really heavy duty eye bolts in those holes and screw that eye bolt in, or have a nut to fasten that eye bolt to the part, and then you can use a chain and feed it through that eye bolt and then hold those heavy parts. And you can put eye bolts at both ends of the part, so you can hang it horizontal, so you can forklift it right into a cart, and then hang chain from both ends from the eye bolt up to your cart, and that can work very well. It also could work on an automated line. You need to make sure the line can actually withstand the weight that you're putting on it. As well as in a batch boost setup, your carts need to be heavy duty enough that you can hold these heavy parts that you're going to try to use eye bolts and chain with. Just because you're going with eye bolts and chain does not mean that, okay, I don't have to worry about it, this is going to hold it no matter what. You need to make sure that you are using a big enough eye bolt. You need to make sure that you're using lifting eye bolts, kind of like these ones that we have. Picture it should be like a metal piece that's got a full circle, and then it's either cast or forged. So it's all one piece, and then you got threads sticking out. There are eye bolts that you can get that are way cheaper. They can still make them in pretty big diameter, that are Not for lifting. They'll even say that typically in the description, don't use this for lifting because it's more of an eye bolt that has threads and then kind of makes a loop, but it stops at the end of the loop and it's not connected to anything that actually can bend open. So you gotta be careful with that. You need lifting eye bolts that are very heavy duty. Eye bolts are typically pretty expensive when you get them big and they're for lifting. And when I say big, I mean like 3/4 inch, 1 inch, but sometimes that's necessary for hanging these very heavy parts. Also, make sure you're using a big enough eye bolt. If the hole in the part is an inch diameter hole, use an inch eye bolt. Don't use a 1/4 inch eye bolt in an inch hole. That seems very obvious because the 1/4 inch eye bolt would be very tiny and you couldn't even hardly fasten it into the hole. But always use the biggest eye bolt that you can because if you use one that's too small, it can still snap or break or deform.